3I Atlas is behaving stranger with each passing day. What astronomers expected was a fading comet, but what they're seeing is something far more unpredictable. 3I Atlas passed its closest point to the Sun on October 30th, 2025, at a distance of roughly 210 million kilometers. It survived that encounter and is now moving outward on a hyperbolic trajectory, which means it is not gravitationally bound to the Sun and will leave the solar system permanently. The velocity of the interstellar comet 3I Atlas relative to the Sun is approximately 210,000 to 221,000 kilometers per hour, which is equivalent to about 60 to 61 kilometers per second. After perihelion, the comet began fading as sunlight and heat decreased, and the rate of outgassing has started to decline. On November 8, 2025, 3I Atlas is positioned in the constellation Virgo, approximately 270 million kilometers from Earth, moving steadily outward. It will make its closest approach to Earth on December 19, 2025, still about 270 million kilometers away, so there is no impact risk. The comet's path will carry it beyond the orbit of Jupiter, 780 million kilometers from the Sun, around March 2026, after which it will fade from detection and continue into interstellar space. Observations from NASA's Hubble Space Telescope, JWST, and the European Southern Observatory's VLT show a coma dominated by carbon dioxide and less water vapor than ordinary comets, suggesting it formed in a much colder region, possibly in another star system's outer disk. The estimated nucleus size is no larger than about 5.6 kilometers, though it may be smaller. 3I Atlas's behavior is already diverging from what we see in typical comets. The James Webb Space Telescope found that the carbon dioxide to water ratio was about 8 plus or minus 1, meaning roughly 8 times more carbon dioxide than water, among the highest ever found in a comet. Observations from the European Southern Observatory's VLT show unusually high nickel and cyanide emissions relative to iron, and a deep negative polarization branch in the light scatter curve, both hinting at material processed under extreme conditions. These changes suggest that the comet's surface, at least the part we're seeing, was shaped by long exposure to galactic cosmic radiation, rather than the pristine conditions of a young solar system. On October 3, 2025, 3I Atlas passed about 30 million kilometers from Mars. During that time, ESA's ExoMars trace gas orbiter turned its Cassis camera toward the comet and successfully captured a moving sequence of images. The first time a spacecraft orbiting another planet has photographed an interstellar object this close. The comet appeared as a small, faint dot surrounded by a soft glow of gas and dust thousands of kilometers wide. Even though the nucleus couldn't be seen directly, the bright coma confirmed that 3I Atlas was still active after its close pass by the Sun. This observation was important because it showed the comet from a new angle, not from Earth, but from Mars' orbit, allowing scientists to measure how its brightness and gas behavior changed as it moved away from the Sun. As of November 8, 2025, 3I Atlas has already passed the Sun and is moving steadily outward through the solar system. After swinging just about 210 million kilometers from the Sun in late October, it is now drifting away and gaining distance every hour. According to NASA's tracking data, it will become visible again from Earth in early December, after moving clear of the Sun's glare. Around December 19, 2025, the comet will make its closest approach to Earth, passing safely at roughly 270 million kilometers, still far beyond the Moon's orbit. From there, 3I Atlas will continue its escape, reaching a distance of about 780 million kilometers from the Sun by March 2026. After that, it will fade beyond the reach of our telescopes, leaving the solar system forever on a one-way path back into interstellar space. From July 2025 to now, astronomers have watched 3I Atlas transform as it moved through the solar system. In early July, when the European Southern Observatory's Large Telescope first captured it, the comet appeared as a tiny compact glow against the background stars, a bright core with a short, condensed coma. That real observation was turned into a 13-minute time-lapse, showing its motion across the sky. By October 3rd, during its pass about 30 million kilometers from Mars, the ExoMars trace gas orbiter observed it from a completely different angle. The comet's coma looked faint and nearly tailless, confirming that solar heating was already decreasing. Now, post-perihelion, its brightness is fading. The coma and tail are shrinking as the comet cools on its way outward. Physically, this is expected. Less sunlight means less sublimation of ice and gas. By early December 2025, 3I Atlas will reappear from behind the Sun, faintly visible again in the pre-dawn sky through large telescopes. On December 19th, it will make its closest pass to Earth, about 270 million kilometers away, far, silent, and perfectly safe. Then it will continue outward, crossing the orbit of Jupiter, nearly 780 million kilometers from the Sun, around March 2026. After that, it fades beyond our reach, becoming just another traveler between the stars. But the data it leaves behind, spectra, dust samples, and its motion through our sky will keep teaching us for years. A brief encounter, yet a long memory in the history of science.